Okay, to start we have question 3, which is the integral of x squared multiplied by the square root of x cubed plus 1 multiplied by dx. So in the question it says for us to use u substitution, where u is x cubed plus 1. So now the first thing we always want to do is what we want to find what du equals, which is 3x squared, and then plus 1 goes away and it's going to be multiplied by dx. So if we rewrite this, just putting the u in, it will be x squared. This will be the square root of u, but we're still multiplying by dx. So we need to find a way to change the x squared and the dx to be in terms of u. So if you look at the du right here, because we know we'll need this for later, we have to figure out a way to make this side x squared multiplied by dx. And if you notice, the only thing there is a 3. So we could get rid of the 3 and then divide 3 on this side. So it will become 1/3 du is x squared multiplied by dx. So we could rewrite our equation as the integral of the square root of u multiplied by du, and since 1/3 is a constant, we can put that on the outside as 1/3. So then it's just an easy integral where you can do 1/3, keep it on the outside. It's going to be u, so instead of 1/2, you're going to go 1/2 plus 1, and you're going to divide it by the 1/2 plus 1 as well. And then the du goes away because we've done the integral. So this gives us 1/3 of u to the 3/2 divided by 3/2. And if you remember fraction rules, we could bring this 2 up top so that we get 1/3 of 2u to the 3/2 divided by 3. Now, this is almost done. All we have to do is replace u with what we had at the very beginning to put it back into terms of x, which will give us 1/3 of 2 multiplied by x cubed plus 1 to the power of 3/2, all divided by 3, and that's the answer for our equation. Okay, next up we have question 4, which is the integral of sine squared theta multiplied by cos theta multiplied by d theta. And in this question, it's u substitution again, where u is going to be equal to sine theta. So here we're going to have the integral of u squared, because the u is replacing the sine, but now we need to find du. And if you know, du is just the derivative of whatever is replacing on this side, which is sine, and the derivative of sine is cos theta times d theta. So for this one, we don't have to do anything tricky because this is perfectly matches up with this. So that gives us du. Now we just multiply by du, and we have an easy integral. U squared now just becomes u cubed over 3, and then the du goes away because we've done the integral. Now, to finish off our equation, all we have to do is replace u with what we had substituted it before for, which is sine. So it's going to be sine cubed theta divided by 3. Question 5. Question 5 is the integral of x cubed divided by x to the 4 minus 5. In this question, they want u to be equal to x4 minus 5. So, just like normal, what we're going to do is we're going to set up and find out what our du is equal to. So, the derivative of x4 minus 5, x4 becomes, you bring down the 4, and then you put x to the power of 3. And then the minus 5 goes away because it's just a constant. But you gotta remember to multiply it by dx, even in the equation, which I forgot. So then what we want to do is we can rewrite our integral. We know that our denominator here is going to be u. from before, so that's nice and easy. But we want it to be in form of du and all in u, so that x to the 3 multiplied by dx has to go away. So we're going to do the same thing before. We know that we want the x cubed multiplied by dx, and the only thing in our way is the 4. So we're going to divide both sides by 4 to get rid of that, and now we just have 4 here. So in our numerator, instead of having x3 multiplied by dx, we can have du. And since we're dividing it by 4, that's just a constant, so we can put that in front of our equation. So now, to make it look even better, we're going to have 1/4 the integral of 1 over u multiplied by du, since that's the same thing as before. Now, this is just a simple integral. 1 over u is going to be 1 over 4 ln of the absolute value of u. Now, to finish up, just like normal, we have to just implement what the u is equal to from the beginning of the question, which gives us 1 over 4 ln of the absolute value of x to the 4 minus 5. Okay, next up we have question 19, which is the integral of cos cubed theta multiplied by sine theta multiplied by d theta. So here we're going to make it easy on ourselves, and we're going to set u right away to whatever has the highest degree, because we'll know that the derivative will be a lot easier. So u here is going to become cos theta. And then right away we're going to find our du, which is just the derivative of cos, which we know is negative sine theta multiplied by d theta. So this is close to what we need, except we have a negative out front. So we're going to do the same thing as always, divide by a negative and divide by a negative, which will just give us negative du is what we are looking for, which is sine theta multiplied by d theta. So we have that taken care of. And we have the cos cubed theta taken care of, because that's what we're replacing with u. So now we're going to have the integral of u cubed multiplied by negative du. But since negative is just going to a constant because it's -1, you could just put that out front. So you have the integral of u cubed multiplied by du to worry about, and then we'll put in the negative after. So now, the integral of u cubed is nice and easy. We're going to put the negative out front, just like always, and we're going to make it u to the 4 divided by 4. And then the du goes away because it's not needed anymore. It's taken care of. So now, we're going to put back cos theta for u, and we're going to have negative out front. We're going to bring the 1 over 4 up front, because that's just a constant. And now we'll deal with the u, which just becomes cos 4 theta. Now, to put it all together, we can just do negative 1/4 cos to the 4 theta. And then since there's no bounds for this integral, we have to always add plus c at the end, because there's a random constant that can be added due to the integration.